The parabola is probably the most familiar shape that we use in math that is a conic. I guess circles are a simpler shape, but we do circles less often, I think, in things like Algebra 2 and pre-cal and calculus and stats. So anyway, parabolas tend to show up more often. As soon as you started back in Algebra 2 learning how to graph y equals x squared, you were dealing with parabolas. The definition of a parabola is a set of all points that are the same distance from a given point, called the focus, and a given line, called the directrix. So notice, a circle is all the points that are the same distance from just one single point, the center. The ellipse and the hyperbola have to do with the distance between 2 points, and parabolas have to do with the distance between 1 point and 1 line. So as far as definitions, that's what makes it most unique, is it is the distance between a point and a line. The point is called the focus, which is the singular of foci, and the line is called the directrix. So on this slide you can see we can have parabolas that are horizontal, facing left or right, which is the one on top, or ones that are vertical, which is what we're more familiar with because those are functions. Like down here, that can be up or down. But our equations do work out a little differently whether we're dealing with a horizontal or vertical. So first of all, if it is the y that is being squared, if that is happening, then you have one that is facing either to the left or to the right. So to find the vertex, notice we're not talking about centers with a parabola. We can find centers on the other conics, but with a parabola we're not finding the center, we're finding the vertex. But the good news is finding the vertex is exactly the same as the way we found the center. It's just what's being subtracted from x, what's being subtracted from y. So hey, that's at least one consistent thing that's nice throughout all the conics. One other thing they may ask you for is the axis of symmetry. So that's this right here. If you look, the shape is going to be symmetric about that line. And you can find the axis of symmetry by doing y equals k, which if you notice, k is just the y value of the vertex. So if you can find the vertex, the axis of symmetry is just a matter of determining whether it's going to be x equals the h or y equals the k. And whatever is being squared, in this case the y, well, and the k I guess as well, is where the axis of symmetry is going to come from. So whatever term is being squared, whatever piece is being squared, that's where the axis of symmetry is going to be. You can also tell the direction of opening, in this case whether it's left or right, by looking at the coefficient that's in front of the part that's not being squared. If the value of p is positive, then it opens to the right, like the example I've drawn. If the value of p is negative, then it opens to the left. So similar things will work out down here. This is when we are having what I'd call more of a vertical parabola, open up or open down. This is what we have when x is being squared. So when x is being squared, our vertex is still hk. It's still what's being subtracted from x and what's being subtracted from y. And our axis of symmetry is x equals h. So again, if you look at the part that is squared, you can almost just draw a line right here. Let me do this over here because it wasn't very good. So it's almost like if you just look inside, just out of the line, you have the axis of symmetry right there. So always look at the squared part for the axis of symmetry. And same idea with the direction. We look at the coefficient in front of the part that's not squared, and if the p is positive, we're open up, like what I drew. If the p is negative, then we're open down. So let's do some examples finding those three things: finding the vertex, the axis of symmetry, and the direction of the opening. So as I look at this equation, I notice that the x is being squared. That tells me right away I'm dealing with one that is vertical. It helps you think about it. Y equals x squared is one you've been working with since maybe middle school even, probably middle school. And you know y equals x squared is shaped like this, so I know it's vertical. Now, because of other signs, it may be upside down, but you know it's that shape. It's either vertical or horizontal. So, let's start with the vertex. The vertex is found the same way we found centers of other shapes. So we look at what's being subtracted from x, which is 2, what's being subtracted from y, which is also 2. And then for the axis of symmetry, we look at the part that is being squared, which in this case is the x term. So we just use x equals whatever its value is in the vertex. So we get x equals 2. And then for the direction of opening, we know it has to either be up or down because this is a vertical one. And to figure out whether it's up or down, we need to look right here and just look at whether it's positive or negative. Since this one is negative, the direction of opening is down. Okay, let's look at one where the y is being squared. Same instructions as before, trying to find the vertex, the axis of symmetry, and the direction of opening. We know this one is going to be horizontal, meaning it's either open to the left or it's open to the right, because the y is what's being squared. So we start with the vertex. We look at what's being subtracted from the x first. Make sure you're always doing the x first. So look over here. We're subtracting a negative 4. And then subtracting from the y, look here. It's a negative 5. Then the axis of symmetry. We look at the part that is squared. This time that's the y. So I do y equals, and I just pull the number that's in the vertex of the y. So it's y equals negative 5. And direction of opening. We know it has to be to the left or to the right, so you do have to commit to memory that when it is y being squared, we're either open left or right. When it is x being squared, we're either open up or down. We look at the coefficient in front of the part that is not being squared. This time it's positive, so that tells us the direction of opening is to the right. Alright, one more thing. Find the vertex, the axis of symmetry, and the direction of opening for this one. You notice this one is not written in standard form, so we're going to have to rewrite it in order to be able to find the vertex, the axis of symmetry, and the direction of opening. So I want to give you a moment to be able to write this down, and then we'll work at it. So our instructions are the same as the other two. We're finding the vertex, the axis of symmetry, and the direction of opening. But we're going to have to rewrite it first. We've got to rewrite it. And we're going to start by separating the x's and the y's. You see y is being squared, so I'm going to leave y's over on the left side. I'm going to subtract the 6x over to this side. And I'm going to have to complete the square with the y, because that's the one that's being squared, in order to make this work. So to complete the square, I need to first get rid of that 4, because I can't complete the square when there's a coefficient other than 1 inside the y squared. So I need to divide every single piece by 4. I am dividing the whole equation, every piece, by 4. And now I need to complete the square. I take the number in front of the y, divide it by 2, that's -1, square it, that's +1, and add that to both sides. And then I need to factor y squared minus 2y plus 1. It will factor to be y minus 1 times y minus 1, or y minus 1 squared. And over here, I need to factor out whatever coefficient is in front of x, which in this case is -3/2. So I factor out the -3/2, leaves me with x, and then 6 divided by -3/2 is -4. So now I have it in its standard form. And now I can find the vertex. That's what's being subtracted from the x, which is 4. And what's being subtracted from the y, which is 1. And for the axis of symmetry, I look at the part that's being squared. That's the y. So I do y equals 1, just pulling from right there. And since y is being squared, I know the direction of opening has to be to the left or to the right. And because the coefficient in front of the part that's not squared is negative, the direction of opening is to the left. So that is everything for part 1 of parabolas. There is a second video we'll do for part 2.